Hi everyone, in this video I'm going to go through the rate function problem that we started working through in class. Even though we were almost all the way through, I'm just going to start at the beginning and work through the whole thing. So kind of watch what you need to watch in order to be able to make progress on the assignment this weekend, because the first two problems do parallel this problem pretty well. So the first thing I want to note is that this is a calculator problem. So we'll be using our calculator. All right. So when I go through these problems, I make sure I read through the problem really carefully and I kind of make notes to myself so I can be really clear on what the problem is about. So on a certain workday, we have the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant, and it's modeled by G of T. So I make myself a note here. I know this is that the rate that gravel arrives, and I know, that the units are tons per hour. So that's kind of everything I know about G. Looks like we're working with the interval from 0 to 8. At the beginning of the workday, T equals 0. The plant has 500 tons of unprocessed gravel. So what they're doing there is giving us an initial amount. And then during the hours of operation, so there's that interval again, those are the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So that's the rate gravel is processed. Or we can think of that's our rate out. All right, so that's what we know. So let's look at the questions here. So my first one is to find G prime of 5. So I'm going to use my calculator to do this. I'm going to make sure that I am in radians mode. And I'm going to use my math 8. So the derivative with respect to x of 90 plus 45 times the cosine of x squared over 18. And I'm finding that when x equals 5. So I get negative 24 point, now you can either put 587 or 588. So I'm going to put approximately negative 24.588. Now here we have to be careful with units. So since I'm doing a derivative, we can think of that as a slope or a ratio. So my units for G of T were tons per hour, but now I'm doing that tons per hour. So my units are going to be tons per hour squared. Now a derivative we know is a rate of change. So this is telling me about how my function, which is also a rate, how that rate is changing. So what we could say is the rate at which G is talking about the rate at which gravel arrives at a plant. The rate at which gravel arrives at the plant. Now we want to talk about how this rate is changing. So since I have a negative derivative here, we would say the rate at which gravel arrives at the plant, we would say is decreasing. Okay, it's decreasing because that was negative at a rate of, now we would just take the value. We've accounted for the negative, so we're just going to take this value. So at a rate of 24.588, we're going to include the units. And we're going to include at time t equals 5, and t was measured in hours. So the rate at which gravel arrives at the plant is decreasing at a rate of 24.588 tons per hour squared at t equals 5 hours. All right, now here we want the total amount of unprocessed gravel that arrives at the plant. So I know arriving, that's my function g of t. And I want to know the amount of gravel that arrives during the hours of operation. Well, I know that's between 0 and 8. Now, I have a rate, g of t. If I integrate that rate over the hours operation, that's going to give me the amount of gravel that came in. Again, we can think about it in terms of units. Time in this case is hours. My rate is tons per hour. So if I multiply tons per hour times hours, I'm going to get tons, or the amount of gravel. So that's why we're doing an integral. So again, I'm going to use Math 9 here, use my calculator from 0 to, not 5, from 0 to 8, 90 plus 45 cosine x squared over 18 dx. And I get 551 tons. Now again, please make sure when you're doing this either for your work on our exams or for the AP exam, it's really important that you write down this integral. The grader wants to see that you knew which procedure to use and that you could also get the right answer. All right, so now it's going to ask us in part C, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? So what I want to do is compare the rate at which stuff is coming in and the rate that it's going out. So if I want to know the rate that gravel is arriving at time t equals 5, I'm going to find g of 5. And let's see if I plug that in. Five squared is going to be 25 over 18. I get 98.141. And that's less than 100. So in other words, the rate that it's arriving is less than the rate that it's processed, which tells me if more is being processed than is coming in, the amount of gravel is decreasing. So we haven't yet answered the question. What we've done is we've shown the work that leads to our answer, but we still have to very specifically answer whether the amount is increasing or decreasing. So once we've shown our work, we would say at time t equals 5, the amount of unprocessed gravel at the plant is decreasing because they're able to process more than what is arriving. So now we've answered the question, and this work here is the work that supports our answer. All right, the last part here, and this is what we did not get to talk about. It wants to know the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday. So if I want to know the amount, I'm going to call the amount of unprocessed gravel, I'm just going to call that A of t. And notice I'm specifying that's the amount here. So I know the amount of unprocessed gravel consists of 3 parts. I have to consider my initial. I have to consider the amount that arrives, which I know is the integral of my rate function. Now notice a couple things here. Since I have t in my bounds, I had to use my dummy variable x here in my function. So maybe I should be clear here and label. So the amount consists of the initial. This is the amount that arrives over an interval. And then I have to subtract the amount that's being processed. In our case, that's 100 times t. So 100 tons per hour times the number of hours that I'm dealing with. So this is the amount that's processed. If I consider all three of those things, that'll tell me how much gravel is left at the plant. So if that's the amount, to find the maximum amount, whenever I'm finding a maximum or a minimum, I know I have to take the derivative and set it equal to 0. Right? That was always our process for finding maxes and mins. So in this case, we're going to take the derivative of this function for the amount. So if I take a prime of t, well, the derivative of 500 is 0, so that's going to go away. The derivative of an integral, if you remember, that's our fundamental theorem. So the derivative of the integral just says, well, I'm going to plug in my upper bound. So I have g of t. The derivative of t is just 1. And since this is a constant, that goes away. So I just have g of t minus the derivative of 100t is just 100. And when I want to find where that's equal to 0. So I know if I can solve for t, I can find the potential time when the amount of gravel is at a maximum. So here's what we're going to do. We're going to use our calculator again. And I'm just going to enter this function into my calculator, and I'm going to find the 0. Okay, so I'm going to go to my y equals, probably got other stuff in there, y equals 90 plus my 45 cosine x squared over 18. So that's my function. Now I have minus 100. And actually, I'm going to go ahead and check my window first. I know my interval, my hours of operation, it has to be between 0 and 8. So I'm going to change my x min to 0, x max to 8. And then we'll go ahead and graph it, and hopefully we'll find a 0. Okay, so I've got 1, 0 I can see right here. So I'm going to do second trace. So I'm going to calc, and I'm going to look for that 0. So let's see here. Whoops. I think I messed this up. Let me go back. All right. I'm going to look for my cursor here somewhere. There it is. So I'm going to put it somewhere above the x-axis. I'm going to hit enter. Then I'm going to move and go out below. Hit enter again, and it's going to tell me that 0 is happening at 4.923. So I have a critical point at t equals 4.923. So now if I want a maximum, this is where we make our options table. All right, I have my value of t and I have the amount of gravel. Now, when we make an option table, we include the critical point as well as the endpoints. So I'm going to do 0, I'm going to test 4.923, and I'm also going to test at 8 to see where the maximum occurs. Well, 0 is easy because we know that was our initial amount. At time 0, it told us that there were 500 tons of unprocessed gravel. So now we just have to figure out our other two values. So to find the amount, I'm going to plug those values of t into this function here. So I'm going to go to my calculator and I'm going to do, let's see, my amount was 500 plus math 9, my integral from 0 to 8 of my rate in. So there's my 90 plus 45 cosine. I should have this memorized by now. X squared over 18 dx, and then minus 100 times, well, our t, whoops, I shouldn't have done 8. That reminds me I need to go back. I actually wanted to find at this critical point, so 0 to 4.923. Sorry about that. Go back here. And then minus 100 times that time 4.923. All right, so I've got 635.376. And now I'm actually going to just go back up here, highlight this, hit enter, and everywhere I had 4.923, I'm just going to change it to 8. So I don't have to type in the whole thing again. Scroll back, here we go. Change that to 8 and delete the rest. And let's see, we have 525.551. Let's see. So now I can look at my table. I can see that the max amount, my largest value, is 635.376. Now, since they want the maximum amount, they're looking for that total amount. So we would say the maximum amount of unprocessed gravel is 635.376 tons, and that would be our answer. Now, it does say justify. In this case, doing your options table, that would count as your justification. All right, so that should give you a good start on trying problems 1 and 2. Again, I really ask that you try to dig into those and see what you can come up with. So try 1 and 2 for the weekend, and then we'll pick up after that when we get back into class. Thank you.